Good evening, America. I'm Kelly McFarland.
And I'm Katrina Hansen.
Tonight we bring you breaking news. You've heard of Sharktopus and Sharknado. Now there's a new monster in our midst, the IR shark.
This poses an immediate threat to the safety of the American population. Such sharks have been known to cause great harm. You are advised to seek shelter and do not go near open bodies of water, as the IR shark's current location is not known. The only confirmed sighting was at a local beach.
We have our reporters in the field to bring you the eyewitness report.
Here at the beach, we take our job as lifeguards very seriously, so when we saw something strange, we decided to investigate. I got all the swimmers out of the water as quickly as possible.
And I took the underwater camera to take a video of it. And this is the shocking footage.
It has now been determined that the IR shark communicates via infrared signals.
We now bring you to two scientists in River Falls, Wisconsin that are working on a way to track the shark so this dire situation may be remedied.
Here is our physical circuit. We have the DAC here. This wire coming from the DAC, it has our 5 volts power. This is the ground. It goes along this line here. Here is the infrared sensitive transistor. Here is our 1K resistor. And this wire here from the DAC goes across the 1K resistor. These wires here are from the digital side of the DAC. They're for the PFIO. It's for the triggering mechanism.
We made this VI to read in the signal from the remote and write it to a spreadsheet. We have the first DAC assistant, which outputs 5 volts to the circuit, and a second DAC, which reads in the voltage signals with a frequency of 883 Hz and 90 samples. The signal from the remote is shown here on the front panel in a graph, and we chose a value around -9 so that values that are above -9 are shown as a 1 and values below -9 are shown as a 0. Then we wrote this data to a spreadsheet in Excel. Now if we run our VI and push button number 8 on the remote, we see that our signal has been generated on the graph, and we can see peaks and valleys from this signal, which should be represented in our spreadsheet as 1s and 0s. So if we go to the spreadsheet, we can see 1s and 0s as we expected.
Okay, here we changed the write to spreadsheet to read a spreadsheet. So we saved the spreadsheet that we wrote to before with the values that we used for when we pushed the 8. And now we're going to test it out again by pressing 8 again and see if we get the same values. And if we do, the equal light should light up. And it does light up, so the values that we got before equal the ones now when we press 8 again.
Now we're going to run our VI continuously as we push each button on the remote and see how our VI responds. 1, 2, 3, 4, 5, 6, 7, 8, and the indicator light is lit up. Now 9 and 0 are both dim, like the others.
We will return to this broadcast after the short commercial break.
Do your eyes itch and burn after a day at the beach? Well, then you should try new Speedy goggles. They're so speedy that you can enjoy a day at the beach any day you want.
For those of you just joining us, we are covering a breaking news story involving the sighting of the IR shark, a deadly species that communicates via infrared signals.
And now, let's return to the 2 students from UWRF who are working on a method for detecting the shark so that this threat may be eliminated.
Okay, so here is our circuit for week 2. We changed it up a little bit from last week. Our resistor now is a 3K resistor instead of a 1K resistor. And our infrared sensitive transistor is now a black instead of clear, because that's just what worked best for our readings this week.
We changed our VI so that we could either save files according to the numbers that we pressed on the remote, or we could read the files that we wrote and compare them to signals that we get by inputting a signal from the remote according to a certain number. So we have a similar setup here to what we had before, but now we have a case structure so that when we are saving files here, it's going to write a file according to which number that we type in here. So we put in a number, and then we can input the signal with the remote on the circuit, and the VI will save the file to that number. In the false section of our case structure, this one is going to take a signal that we input, and it's going to compare it to all the sets of data that we saved to the files before for numbers 0 through 9 for those signals. And it will tell the user what their number is on the front panel.
The circuit may now be used to locate the shark.
Thanks to the signal detecting technology used by 2 students in River Falls, authorities have now confirmed the capture of the IR shark. The IR shark is no longer a threat to the community.
Well, that's all the time we have tonight, folks. I'm Kelly McFarland.
And I'm Katrina Hansen.
Have a good night and a pleasant tomorrow.